All right, gang, we're going to be working now on worksheet 5.5. We're going to talk about triangle inequalities, long sides, short sides, large angles, small angles. The first section is dealing with finding the largest and smallest angles. It says name the smallest and largest angles of the triangle. Question number 1, the information that we have is the length of the sides. We notice that 9 right here is the largest side. And so to find the largest angle, we go with the angle that is opposite of that. And that would be angle M over here, the angle that does not touch the red line. So we can fill that in right there, angle M. And then we have to find the smallest angle. So now we're looking between the 5 and the 6. Clearly this 5 side right here is my shortest side. So the angle that is the smallest is the angle over here that does not touch that. Notice the two blue things do not touch each other at all. The smallest angle is angle N. So if you draw those lines on there, I think that will help you find the opposites. Then we're going to move on and we're going to name the shortest and longest sides of the triangle. So again, we're going to do the exact same thing, except we're going to look at angles first. And in this triangle, we're going to start actually here with number 7. You notice 7 is different than 5 because 7 is missing an angle. Whenever that is the case, you need to always find that angle first. It appears that 71 is the largest and 42 is the smallest, but you're just not sure. So remembering that there are 180 degrees in the triangle, we can take the 71 plus the 42. 113, take 180 minus 113, and it turns out that this angle right here is 67 degrees. Now we know for sure that 42 is our smallest angle. That means the shortest side has to be the one opposite. Again, remember, notice that the blues do not touch each other. To name that side, you have to use the 2 letters, the A and the C. AC with the bar above it. Then to name the longest side, we find the largest angle, 71, and then we find the side that does not touch that, opposite of that, and that is AB. Remembering that those letters can go in either order. It does not matter, those would both be fine. The next chunk of problems talk about triangles in general, and you need to decide if the numbers given even make a triangle. For 9 and 10, you're looking at those sides, and remember the most important are the 2 shortest have to be more than the longest. So that really is your focus, but remember the definition is the sum of any 2 sides is more than the third side. For question number 11 here, it says describe the possible lengths of the third side of the triangle, given the lengths of the other 2 sides. And so what we need to do here is figure out what the third side could be, and there really are infinite number of choices, but it falls in a certain range. To find that range, you simply need to take the 2 numbers and add them together, and the 2 numbers and subtract them, and those 2 answers will give you the range that the third side must be. This question mark right here has to be somewhere between 6 inches and 18 inches. So the shortest way to write that is in a mathematical sentence. That x will be between 6 and 18. But if you're not comfortable with that, you can write it as a sentence in words. The third side is between 6 inches and 18 inches. Whichever way you like, you can write it mathematically or as a sentence. Now when we're describing the possible values of x, this really is the exact same question as the last one. They give us 2 of the numbers, and we have to find out what the third number can be. So again, we take these 2 numbers and we add them together, and we subtract them, and I know that this third third side right here has to fall somewhere between 12 and 2. But now we have an equation or an inequality that we need to solve. So we take that third side, 2x minus 2, and we put it between the other two sides. And this is like an equation, except that it has now 3 parts to it, but we solve the exact same way. We take that number in the middle and we add 2, but now we need to do it to all of the parts. On the left, 2 plus 2 is 4. In the middle, negative 2, positive 2 cancel out, so we have 2x. And on the right, we have 12 plus 2 is 14. And then the last step would be to divide by the number on the x. And again, we divide it on all the parts, and we get 2 and x and 7. And we know that x has to be between 2 and 7. If I look at question 16, again, I'm not going to do the whole thing, but again, we're going to set it up. We have to take these two numbers to help us determine the third. Remember, you add those two numbers, and you subtract those two numbers, and I know that this is what we have to be between. So 2x plus 2 has to be between 4 and 20. And you're going to go from there, solve that inequality, and find out the range of the x value. For question number 18 and 19, we will be drawing a triangle. And when we're doing this, everybody gets to draw their own triangle, but surprisingly, they all end up to look very similar, because everything has to be opposite the right sides and angles. So it says the side lengths are 14, 17, and 19, with the longest side on the bottom. The angle measures are 45, 60, and 75, with the smallest angle at the right. So the first thing I would do is order those numbers, 14, 17, 19, from small to big. And I'm also going to order my angles from small to big. Remember, these are all degrees, and the angles in the sides have to be opposite of each other. So if we organize everything, we will know how to arrange our triangle. When we look in here, remember that the longest side has to be on the bottom, so we're going to put the longest side on the bottom, and that would be our 19 right here. And that automatically tells us that 75 has to go opposite of it, because they are both the largest and the longest. And then it says that the smallest angle has to be at the right. So I know that this is my right side, and I choose my smallest angle, which is the 45. Remember, angles go inside the corners. Opposite the 45, over here, I have to put the smallest or shortest side, 14. And that only leaves the 60 and the 17 left. Everybody should have a triangle that looks similar to that. Organize your information, start the drawing, match everything up. And then these last couple questions, you have to decide, is it even possible to draw these triangles? Remember that the sum of any two sides has to be more than the longest, or more than the third side. And again, the two shortest sides are really the two most important sides. So in this case, I look and I see that 4 and 5 are my shortest numbers. So I take 4 plus 5, and that gives me 9. I compare that to 6. Is 9 larger than 6? And indeed it is. So we do have a triangle. If I look at question number 21, again, we're choosing the two smallest sides and comparing it to the largest side. So in this case, my 1 and my 4 are my two smallest sides. So I will be adding the 1 plus 4 together. That equals 5, when I compare that to 6, is 5 bigger than 6? No, it is smaller. So this is not a triangle. The two smallest must be larger than the biggest. Good luck. See you tomorrow in class.